Hi, I'm Ahmet from Xata. Today I'll show you the transformers, one of the latest features of pgstream. We can use transformers during replication and snapshots, and the main purpose is to prevent sensitive data leaks. So this is an example transformation config. With this config, pgstream will be masking the values in the column email of the table users. For masking, we have support for 10 different masking functions, thanks to the open source library GoMasker. For instance, if we use the password masking function, it simply masks the data entirely. But if we use the email masking function, it keeps the domain part as is, while partially masking the first part before the domain. But what if we want to mask the domain part as well? If none of these supported masking functions work for you, we have a solution for that as well. Here we have the custom masking option, where you can specify what part of the data will be masked and what part of it will remain unmasked. For this example, we will be masking all the values in the specified column, starting from index 4 up until index 12. But what if we have no idea about the length of the input? An address, for example, an address can be 10 characters long, but it can be 50 characters long as well. For these cases, we use relative indexes using percentage points. But this one, for example, we simply tell pgstream to keep the first and the last 15% of the data as is, while masking the rest in the middle. Alternatively, we can configure a custom masking function to leave the first 3 characters unmasked while masking all the rest. So that's pretty much it for the masking part. We also have transformers for generating anonymized data, each for a different data type. Let's take a look into the integer one, for example. We can specify the generator to behave randomly or deterministically. The default is random. We can specify the minimum value, the maximum value, and the size of the integer to be generated. Now let's test it. We will use this transformation config for testing purposes. It's under the modifiers section of the pgstream configuration file. We will be transforming the data in the table test in the public schema. So for the name column, we will be using the first name transformer from GreenMask, an open source library, which generates a new first name for this column. But we don't want to name someone who is a female with a new male name. So for that, we have dynamic parameters. Here, we simply tell pgstream to look up to some other column named sex and use that information when generating a new first name to that person. So if he's a male, he will get a new male name. If she's a female, she will get a new female name. For the column last name, we will be generating random strings. They won't be real last names. We will be masking the email column using the email masking function, and we will be masking the address column using our custom function, which keeps the first 10% of the data untouched while masking all the rest. For the column total purchases, we will be using this integer transformer, which generates deterministically a new integer between 0 and 1000. For the birth date column, we will be generating a new random date between 1980 to 2000. For the heart rates column, we will be using this literal transformer, which simply puts an empty JSON object as the new value. So here we have 2 different Postgres servers. In the first one, I've created a table and inserted 2 rows. In the second one, that table doesn't exist yet. In this table, we have John and Jane with their last names, emails, addresses, total purchases. Their total purchases are the same. They have birth dates, they have sexes, and they will get new names according to their sexes. And as heart rates, they have simple JSON objects. Let's kick it off. Now pgstream has created the table test in the second Postgres server. Here we can see that John is now named Rosento and Jane is now Agnes. They have random strings as their last names. We have masked their addresses and email addresses, and we have masked their addresses using our custom masking function, which keeps the first 10% of it unmasked while masking the rest. Their total purchases are again the same because in the configuration file, we have set it to behave deterministically. So it means it will always produce the same output for the same input. And because they have the same value in the original table as their total purchases, they will have the same value in the new table as well. They have birthdays randomly generated between 1980 to 2000, and they have empty JSON objects as their heart rates. So thank you for watching. I hope you like it just as we do.